So, in number 8, which is y double prime plus y prime is 0, we sub in y equals e to the rt. We got r squared e to the rt plus r e to the rt is 0. And then you factor out an e to the rt and disregard it. So you got r squared plus r is 0. And then you factored that to r times the quantity r plus 1 is 0. And from that you got roots of r is minus 1 and r is 0. And then you plug those in, and you get y is b plus a e to the minus t, and you're like, okay, I believe I solved the differential equation, but like, what the hell about the spring? Right, because all these should be a spring. Mm-hmm. So I'm kind of used to having springs that don't oscillate, right? Like, that happened the first day. But what the hell? Why is there this b in here? Like, why is there a constant solution? Well, so what are the spring constants? Just remember. So the general form for these is my double prime plus b y prime plus ky is 0.
0 k.
Yeah, that k is 0.
Oh,
That's kind of funny.
wow, that's really.
This isn't a spring. It's a
really
friction problem.
It's a really loose spring.
Right. That's why the b is constant is the solution, because if you put it somewhere and it's not moving, it's going to stay there. Does that make sense? So some of these are weird springs. You have to keep an eye out on them a little bit, like this
So-
previous one you did.
This is still a spring though?
At least it's a spring kind of thing. This one, where I got a e to the 2t plus bt e to the 2t, that's what's called an anti-damped spring.
It's going to speed up as you go.
Like, if you think about it, right, it's got a spring coefficient of 4 and a friction coefficient of minus 4. That means if it's moving, it tends to accelerate. Right? Friction imparts energy in the system instead of stealing it.
Wouldn't that just kind of self-destruct at a certain point? Like,
Oh, yeah.
Well,
Can you
it'll
see
go
that?
to infinity, right? As you run t
Yes.
forward, then yeah, it'll go to infinity.
like any real physical spring, can you like add something in there to show that it can't just?
So that'd be a domain question, right? So the valid domain for this is probably not the real numbers for t, which is exactly what's kind of going on. And these are really models for springs, right? Every actual spring system is going to have a limit to how far you can go on it, because the spring is made out of atoms, and the best you could do, even in the kind of limit of things, is putting atoms kind of next to atoms and making a one atom like hair out of all your spring. And that's probably not super realistic, right? Cool? Questions?